Lesson 2. Basic process in system development. 2.1. Introduction. In ergonomics, each of the human, machine and environment has an effect on the complete system. The basic components of each are: A. Human components. Sensors, through which a human is made aware of its surroundings. Human being has 5 senses, namely sight, hearing, touch, taste and smell. Information processor. This includes joints, muscles and memory to provide information and feedback, and brain to act as information processing system. Affectors. The 3 primary affectors are the hands, feet and voice. However, the whole body more can be regarded as affector because no physical activity can be carried out without its supporting role. B. Machine components. Displays. These include gauges, dials, meters, indicators, etc. and provide information about status and working of machine to the operator. Controls. These include components of machine like steering wheel, accelerator, clutch, brake lever etc. through which a human changes and control action of machine. Controlled process. This is the basic operation of machine in its local environment as controlled by the human. C. Local environment. It is the place and circumstances in which work carried out. It consists of workspace. It is the 3-dimensional space in which work is being carried out. It is decided by dimensions of the machine, anthropometry of human and space required for activities of human and machine. Physical environment. It means the local environment factors having a bearing on the complete system. It includes noise, vibrations, lights, exhaust, climate etc. Work organization. It refers to the organizational structure in which work activity is embedded. It includes role of human and machine in system, organization and other persons of the team upon which the performance depends. (2.2) Objectives of ergonomics. While planning of the human factors in ergonomics, the objectives and end goal required is to be taken into considerations. These objectives may be one or a combination out of the following: A basic objective, to improve system performance, to reduce errors, to increase safety. B. Objectives concerning users and operators, to increase ease of use, to reduce fatigue and physical stress, to improve the working environment, to increase user acceptance. C. Objectives concerning reliability and logistic support, to improve reliability, to reduce maintenance, to reduce labor requirement, to reduce training requirement. D. Other objectives, to improve system efficiency, to reduce cost of production. 2.3. Human-technology interaction. Ergonomics and technology have a specific role to play with each other. The technology can be defined as entire system of people and organizations, knowledge, process and devices that go into creating and operating technological artifacts. Technology is a product and process involving both science and engineering. Engineering represents design under constraints of cost, reliability, safety, environmental impact, ease of use, available human and material resources, manufacturability, government regulations, laws and politics. Ergonomics discovers and applies information about human behavior, abilities, limitations and other characters to the design of tools, machines, systems, tasks, jobs and environments for productive, comfortable and effective human use. The basic issues and processes covered under ergonomics for design and development are: A. Human characteristics, psychological aspects, physiological and anatomical aspects, group factors, individual differences, psychophysiological state variables, task-related factors. B. Information presentation and communication, visual communication, auditory and other communication modalities, choice of communication media, person-machine dialogue mode, system feedback, error prevention and recovery, design of documents and procedures, user control features, language design, database organization and data retrieval, programming, debugging, editing, and programming aids, software performance and evaluation. C. Display and control design, input devices and controls, visual displays, auditory displays, other modality displays, display and control characteristics. D. Workplace and equipment design, general workplace design and buildings, workstation design, equipment design. A. Environment, illumination, noise, vibration, whole body movement, climate, altitude, depth, and space. Other environmental issues. F. System characteristics, general system features. G. Work design and organization, total system design and evaluation, hours of work, job attitudes and job satisfaction, job design, payment systems, selection and screening, training, supervision, use of support, technological and ergonomic change. H. Health and safety, general health and safety, etiology, injuries and illnesses, prevention. I. Social and economic impact of the system, trade unions, employment, job security, and job sharing, productivity, women and work, organizational design, education, law, privacy, family and home life, quality of working life, political comment and ethical considerations. J. Methods and techniques, approaches and methods, techniques, measures. 2.4. Factors considered in system development. Some of the important factors considered in design, testing and evaluation of man-machine environment system are as listed by Dull and Weirdmeister, 1993. A. Anthropometric, biomechanical, and physiological factors. Are the differences in human body size accounted for by the design? Have the right anthropometric tables been used for specific populations? Are the body joints close to neutral positions? Is the manual work performed close to the body? Are any forward bending or twisted trunk postures involved? Are sudden movements and force exertion present? Is there a variation in worker postures and movements? Is the duration of any continuous muscular effort limited? Are the breaks of sufficient length and spread over the duration of the task? P. Factors related to posture, sitting and standing. Is sitting, standing alternated with standing, sitting and walking? Is the work height dependent on the task? Is the height of the worktable adjustable? Are the height of the seat and backrest of the chair adjustable? Is the number of chair adjustment possibilities limited? Have good seating instructions been provided? Is a footrest used where the work height is fixed? Has work above the shoulder or with hands behind the body been avoided? Are excessive reaches avoided? Is there enough room for the legs and feet? Is there a sloping work surface for reading tasks? Have combined sit-stand workplaces been introduced? Are handles of tools bent to allow for working with the straight wrists? C. Factors related to manual materials handling, lifting, carrying, pushing and pulling loads. Have tasks involving manual displacement of loads been limited? Have optimum lifting conditions been achieved? Is anybody required to lift more than 23 kilograms? Have lifting tasks been assessed using the NIOSH method? Are hand grips fitted to the loads to be lifted? Is more than one person involved in lifting or carrying tasks? Are there mechanical aids for lifting or carrying available and used? Is the weight of the load carried limited according to recognized guidelines? Is the load held as close to the body as possible? Are pulling and pushing forces limited? Are trolleys fitted with appropriate handles and hand grips? D. Factors related to the design of tasks and jobs. Does the job consist of more than one task? Has a decision been made about allocating tasks between people and machines? Do workers performing the tasks contribute to problem solving? Are difficult and easy tasks performed interchangeably? Can workers decide independently on how the tasks are carried out? Are there sufficient possibilities for communication between workers? Is sufficient information provided to control the tasks assigned? Can the group take part in management decisions? Are shift workers given enough opportunities to recover? A. Factors related to information and control tasks. I. Information. Has an appropriate method of displaying information been selected? Is the information presentation as simple as possible? Has the potential confusion between characters been avoided? Has the correct character, letter size been chosen? Have texts with capital letters only been avoided? Have familiar typefaces been chosen? Is the text, background contrast good? Are the diagrams easy to understand? Have the pictograms been used properly? Are sound signals reserved for warning purposes?
E. Control is the sense of touch used for feedback from controls. Are differences between controls distinguishable by touch? Is the location of controls consistent, and is sufficient spacing provided? Have the requirements for control display compatibility been considered? Is the type of cursor control suitable for the intended task? Is the direction of control movements consistent with human expectations? Are the controls objectives clear from the position of the controls? Are controls within easy reach of female workers? Are labels or symbols identifying controls used properly? Is the use of color in controls design limited?
E. Human-computer interaction. Is the human-computer dialogue suitable for the intended task? Is the dialogue self-descriptive and easy to control by the user? Does the dialogue conform to the expectations on the part of the user? Is the dialogue error-tolerant and suitable for user learning? Has command language been restricted to experienced users? Have detailed menus been used for users with little knowledge and experience? Is the type of help menu fitted to the level of the user's ability? Has the QWERTY layout been selected for the keyboard? Has a logical layout been chosen for the numerical keypad? Is the number of function keys limited? Have the limitations of speech in human-computer dialogue been considered? Are touchscreens used to facilitate operation by inexperienced users?
F. Environmental factors. I. Noise and vibration. Is the noise level at work below 85 dBA? Is there an adequate separation between workers and source of noise? Is the ceiling used for noise absorption? Are acoustic screens used? Are hearing conservation measures fitted to the user? Is personal monitoring to noise, vibration used? Are the sources of uncomfortable and damaging body vibration recognized? Is the vibration problem being solved at the source? Are machines regularly maintained? Is the transmission of vibration prevented?
E. Illumination. Is the light intensity for normal activities in the range 200 to 800 lux? Are large brightness differences in the visual field avoided? Are the brightness differences between task area, close surroundings, and wider surroundings limited? Is the information easily legible? Is ambient lighting combined with localized lighting? Are light sources properly screened? Can light reflections, shadows, or flicker from the fluorescent tubes be prevented? E. Climate. Are workers able to control the climate themselves? Is the air temperature suited to the physical demands of the task? Is the air prevented from becoming either too dry or too humid? Are drafts prevented? Are the materials, surfaces that have to be touched neither too cold nor too hot? Are the physical demands of the task adjusted to the external climate? Are undesirable hot and cold radiation prevented? Is the time spent in hot or cold environments limited? Is special clothing used when spending long periods in hot or cold environments? Please subscribe, like and share. E. Control. Is the sense of touch used for feedback from controls? Are differences between controls distinguishable by touch? Is the location of controls consistent? And is sufficient spacing provided? Have the requirements for control display compatibility been considered? Is the type of cursor control suitable for the intended task? Is the direction of control movements consistent with human expectations? Are the controls objectives clear from the position of the controls? Are controls within easy reach of female workers? Are labels or symbols identifying controls used properly? Is the use of color in controls design limited? Basic process in system development.